Hi everyone, it's Nick Pavlov here. I am back with the DAX tutorials, and in this video I wanted to take a deeper dive into the calculate function. We already looked at the basics of calculate in the previous video. However, since this function is so important and commonly used in so many use cases, I wanted to spend more time looking at it and explaining these use cases. Before I start, let's quickly remember what the calculate function is. So calculate is all about understanding and properly using the filter context in DAX. In real life, most business reports need calculations that depend on specific conditions, such as revenues in a particular country, filtering by a date range, or intentionally ignoring certain filters. Without calculate, you are at the mercy of whatever filters and slicers the report user selects. So if I select 2014, then my sales number are going to show me the 2014 numbers, and so on. If I have other filters, then obviously I can filter by country, product, whatever. And all of your calculations are going to change based on these filters. And that's why in many cases we need to use calculate, because with calculate you can control and ensure that you are making accurate comparisons. You can do trend analysis, conditional logic, and other business insights. So let's go ahead and look at several use cases where we should use calculate and break down the code, the logic, and understand why we have to use calculate. So in the first example, let's look at the scenario of fixing a calculation to a specific year. Imagine that you are looking at performance and you always want to see 2014 sales as a reference, even when users select different years in a slicer. So let's call that total sales 2014. Let me make this larger, and we're going to use calculate. And that's going to be inside of that is going to be a sum of the sales amount from my fact sales table, okay? Instead of using sum, what we can do, we can use the total sales measure, because I already created the total sales measure, which equals to sum of a sales amount column. So instead of writing sum sales amount all the time, what we can do is just replace it with an existing measure. And in the filter, I'm going to use date, and that's going to be year equals 2014. So this calculation will always show you the total sales for 2014, regardless of any external filters. Let me format this and add it to my table. And right now I have, obviously my slicer is selecting 2014, so I have exactly the same numbers here. However, when I select 2015, this number is going to change and 2014 will stay the same. It will always show me the 2014 numbers. Let me actually add a card visual here. So that's going to be a card and total sales for 2014 right here. Maybe it makes sense to remove this and actually put month in my rows. No, I wanted to do a cluster column chart. So I'm going to have month. And this makes more sense. So I can, for example, compare 2014 with others. So 2014, the dark blue always stays the same. Now, imagine you have a scenario where you need to compare the 2014 online sales versus total sales in other years. So what we can do is we can go back to our measure, which we just created. Okay, let me actually do indentations here properly. And we can add to the existing measure, we can add another filter. So that is going to be, I have a table called channel, and there I have a column called channel name. Channel name equals to online. And the name of my measure then will be total sales online in 2014. So I'm calculating from the total sales, I am filtering only for 2014 and channel name online. So I only want to see the online sales in that year. And when I do that, here's my online sales. They're a lot smaller than general sales. Let's go to use case number 2. And in this use case, we're going to filter by dynamic conditions. Let's say in this example, your task is to track the sales for large orders only. For instance, those where the order quantities are greater than, let's say, 50 units. Let's go ahead and create another measure. And this is going to be sales of large orders. We're using calculate, of course. And it's going to be total sales, the measure that we have in the filter section, okay? Here we're going to use the function called filter. And inside of that, we're filtering the fact sales table by this condition. So quantity is greater than 50. All right? So here we can replace our card. We can put this new measure in our card. So sales of large orders is 54 million. And here we can use the tree card. I will put the sales of large items, so large orders, and then filter it by product category. So product category name. And we can see that in 2015, cell phones, computers were the most popular items. Total revenue of items that were sold in the amount more than 50 were cell phones, followed by computers. All right, so I hope this is clear. Now let's move to the use case number 3, which is time intelligence calculations. In this use case, we will track last year's sales and compare trends in performance. And the way to do that is by using the year-over-year calculations. So let me go back to the matrix visual again, okay? Let me put my month in rows. And then I will put the measure called total sales right here. Okay, so then let me first create the measure to calculate the previous year's sales. So I am here in 2015. I'll create a new measure. Total sales, PY, previous year. Calculate function, of course, total sales, again, all the same. And then in the filter context, we're going to use the formula called same period last year. Same period last year. And then inside of that same period last year, we're just going to use the date column from the date table. Very easy, right? That's it. Let me add this to my matrix, format it to save space. And now I have the total sales for previous year. So I am filtering for 2015. I can now actually remove this card. I don't need it. So I'm filtering by 2015, and then here the total sales are this much, right? And then the total sales previous year are this much. It actually probably makes sense now to put total sales previous year before the total sales, so it is visually easier for us to understand. What makes sense next is to analyze the year-over-year growth. So how much growth or decline we had from previous year to the new year, right? So to do that, I will go back and create a new measure, year-over-year growth %. And this is simple math, really. We're going to be dividing the difference between this year's sales and last year's sales, okay? And we're going to divide that by the total of previous year to find out the % difference. Okay, so we're going to be using formula called divide, and in the numerator, it is going to be total sales. It's going to be total sales minus total sales previous year, and then divided by total sales previous year. So the difference between this year and last year divided by last year. Okay, so now let's add this to our table, format this as a %. Turns out that I have a negative trend, so everything actually went down compared to last year, all right? So such is a data set. Now, lastly, let's calculate the running total or cumulative sales for a selected year. Running total is a calculation where each month is added to the previous month. So January, February, March, etc. is all added up until we have the total for the year. Let's go ahead and create that measure. Running total sales. And we're going to be using calculate again, right? Calculate, again, total sales. The same measure we're using all over and over again. And then in the filter context, we're going to be using formula called dates YTD. Right here, okay? And then here we just basically need to indicate the date column from our date table. Okay, so we create this. Let's add it to our table. Let's format it with 0 decimals to save space. And now here we have, this is our running total for the year of 2015. To demonstrate this better, let me actually put area chart right here. Let's put month, okay? And running total sales. And here we have a better visual. We can also add total sales. So we have total sales more or less, at the same level, but then we have, every month is adding up. This is the cumulative sales, okay? So these are the examples of time intelligence functions and how you can use calculate to create them. All right, so use case number 4. In this last section, I'd like to look at some advanced use cases of calculate to work with some product-related analysis, okay? First, let's say you want to dynamically identify the top-selling product based on revenue for each time period, okay? So for each month, we want to know which product was the best-selling product based on total sales, based on the revenue, okay? So what I'm going to do is I'll go to this table and I will remove all of this. And then I'll create a new measure, okay? So we are going to call this top selling product, calculate, and then inside of a calculate, we're going to use the function max, okay? And inside the max, we're going to go for the product name, and then I will explain the logic of a formula, okay? Let me first write it, and then we will break it down, what means what. And then it's going to be top n, which brings the top n expression from a table. And then here is going to be 1, and 1 means, the top selling, the first selling product. Followed by values, and the values, this is where we indicate the table. This is going to be product key. Oops, I forgot parentheses. Product key. And then I'm filtering it by total sales. And we're going to go descending. Descending because we want the highest value. Seems to be an error somewhere here. Values. Oh, yes. There we go. Be careful when using DAX. It's always little comma here or little parenthesis here in your formula. Let me add this to a table. And here we have it. For each month, we have the top selling product. So let's go over the formula a little bit here. So this formula here gets a list of all distinct product keys from the table. It gets the top one product based on the highest sales. Descending here means the highest. And after that, the max will return the name of the product to our table right here. All right, and lastly, let me show you one other use case, that is the calculation of products that have never been sold, also known as the dead stock in a warehouse. So in your stock, you can have a number of items that nobody ever bought or nobody ever buys. And these items are just dead weight, and you might want to think how to get rid of them. Go to my folder here, table for measures, and then create that measure. I'm going to call that dead stock. Again, calculate. And then inside of a calculate, we're going to use a formula known as count rows. and we're going to be counting rows in the product table, okay? So then we're gonna go not in product key. Again, let me do the formula and then I will explain the logic, okay? IntelliSense is in my way, so in values, and that is going to be a product key as well. Okay, so that's it. What I can do, I will remove this and add the new measure, dead stock. So in this example, this is a Contoso dataset. Obviously, it's a clean dataset, accurate dataset, and I don't have any items that fit into this criteria. But in reality, you will have, most likely you will have a lot of items that were never sold. Okay, so let me explain the formula. This part here in the bottom checks each product in the product table and will filter out any that have ever been sold. So which means the remaining products are those with no sales. Then we have the count rows that will count how many products exist after applying the filter. So in other words, we're counting how many products have never been sold. And that means products that exist in the product table but did not appear in the fact sales table. In this example, it didn't work because this is the demo data set and it's a clean data set and all products in the product table were sold. All right, that's it for today. Hopefully you liked this video. I showed how to use the calculate function in different scenarios to control filter context and perform dynamic calculations across your data. As you could see, calculate is used to perform all kinds of business requirements and analysis, and it's absolutely must-know formula in DAX. Please like and subscribe, and follow us for more videos on Power BI, Microsoft Fabric, and analytics in general. Please take care of yourself, and if you can, of someone else as well. Talk to you later. Thank you very much.